The next session will begin shortly. Please be seated for smooth operation. Please put your cell phones on vibration mode. Today's session will be provided with simultaneous interpretation. There is a channel set in your interpretation device. If you want to hear Korean, you can set your channel to number 3. If you want to hear English, please set your channel to number 4. We will begin the session. Hello, I am Tang Hari from Sejong Innovation Center, and today's theme is Rethinking Plastic, a Sustainable Circular System. And thank you so much for participating today's event for plastic rethinking. And today we have 3 experts for presentation, and then they will be given for 15 minutes. And after that, we will have a
And first, let us begin with the first presentation. First and foremost, we will be joined by Mr. Middleoff from Steinart to GmbH. And please come forward. Please welcome him with a big round of applause.
Hello, everyone. Very nice to be here. Very happy for the invitation that I get a chance to present my company and our solutions. Okay. Hope this is better. Thank you very much for inviting me. I'm happy to be here. Like was said, my name is Thorsten Mittelhof, head of regional sales for MENA and Asia region from Steinert. We are a company based in Cologne in Germany and specialized on magnetic and sensor sorting. This presentation is about sensor intelligence for waste sorting by the utilization of big data and AI. Steinert's mission is to help with the circular economy, which is one crucial implementation of to achieve carbon neutrality. In our industries, we already have very defined processes from raw material to products, and our mission is to close the loop to a circular economy. Just as an example, one very difficult task is to separate food and non-food grade PET bottles that we get asked for a lot because the mission is, of course, not to use food grade PET bottles to create clothing, for example, which is happening a lot, but to create a circular economy within this product so we can reutilize food grade PET bottles as food grade PET bottles again. So in this presentation, there's going to be a lot of things, but at the end we learn a little bit how to achieve that. So first, to introduce my company a little bit. We were founded in 1889 in Germany, mostly at start for magnet separation, and then later on developed also different types of sensors. We are acting worldwide. We have subsidiaries in Australia, Brazil, 2 subsidiaries in Germany, including plus our headquarter, and 1 subsidiary in the US, with a turnover around 180 million euros and 550 people. We are a so-called medium-scale company in Germany. This is the map of operation. Like I said, in US, Brazil, Australia, and 2 times in Germany, we have subsidiaries. In Germany, we are manufacturing machines for glass sorting in our subsidiary near Hamburg in Wedel, and NIR sorters, near infrared sorters, in East Germany, close to the border of Poland and Czech Republic. And in our headquarter, we are manufacturing since 130 years magnets and other type of sensor sorters like inductive sorters, combination sensor sorters, X-ray sorters that I'm going to present. Otherwise, we have a lot of representations around the world, and here in South Korea we have Peritos. Samling is also here with me to be closer to you, of course. Next, I'm going to present what high-quality sorting technology is about, what we can offer for which applications. First, a little bit for my division. We have 4 divisions in total. The waste recycling division that I'm participating in is taking care of sorting household waste, commercial and industrial waste, construction demolition waste, sorting different types of plastic, cleaning compost, waste to energy products like refuse derived fuel, for example, where it's very important to take out PVC because the chlorine content should be low. Separate paper, which is already, I think, very developed to have almost circular economy to be reused many times, and many other applications. Then I have some colleagues for the metal and scrap recycling, which is, of course, also an industry where it's relatively easy to recycle the material and no need or not much need for raw material from ores. Colleagues from glass recycling, another one where it's relatively easy to achieve 100% circular economy, and then some colleagues from mining. Some overview of our magnet-based sorting technologies. We differentiate in 3 different intensity levels. For the low intensity, we use magnet drums and overband magnets, for example, for materials that are very easily magnetized. So those can be taken out relatively easy from the waste streams. Medium intensity, we call, for example, our eddy current, where we take out non-magnetizable, non-ferrous metals, such as aluminium, copper, zinc, and so on. And then, which is not really part of the waste division, but more for mining, for example, is high intensity for very low or very difficult to magnetize minerals. Then we have the sensor-based sorting, which is probably the most important in total for waste recycling. We use different type of arrays, basically divided by the wavelength. For the X-ray sorting from 0.1 to 10 nanometers, we have 2 different technologies: X-ray fluorescence, where we basically look at the surface of the material, where we can see the chemical composition. Is mostly used in metal and mining, where you can see, for example, the difference of copper and brass and zinc. The X-ray transmission is a density-based sorting. So basically with the transmission of the X-rays, we can see how dense a material is, which is also very important to separate different kinds of minerals and metals. But also in waste, for example, if something is hidden within plastic that you don't see from the surface, with X-ray transmission we can find out things like that, for example e-cigarettes or something like that, where you have a battery hidden inside a plastic body. Then we use visible light, 400 to 700 nanometers, basically mostly for color sorting or just to identify the shape of the material, where we have our combination sensor sorter, for example, flake sorter, or just a simple color sorter. Most important for my division is the near-infrared sorting with wavelengths of 700 to 2000 nanometer, where we do basically the sorting, the identification of material based on the near-infrared spectrum, by which we can define a lot of different materials, mostly plastic, wood, but many others as well. A special version of that is the medium infrared sorting with, for example, our black eye, where we can even see differences in black plastics, which is otherwise very difficult because most of the light is absorbed by the carbon inside the black plastics. But we found a solution to even sort black plastics by type. And then we also use radio waves from 1 meter to 1 kilometer wavelength, basically for the identification of metals in the waste stream that still pass through after magnetic and eddy current sorting, basically mostly stainless steel that could still be in the wave stream. Now I'm going to present you some solutions for plastic sorting. Of course, it's always just an example because it can be very complex. First, a bit more about the near-infrared technology, which is the most important technology for plastic sorting. Here you see a typical in-feed of light material packaging waste. Of course, in every country, in every commune, it will look differently. I think this is an example from Belgium because they use a lot of the blue plastic sacks. But no matter what your input is, we are there to help to create an individual process, which of course depends a lot on what in-feed you have and what output you expect. And in between, we try to find the optimal way for you to separate. Generally, for the plastic sorting, for the light packaging waste, pre-treatment is of course very important, which usually starts with pre-shredding, where we open the bags and loosen up compounds. Then the material is screened, sent through a wind shifter and a ballistic separator to create basically, mostly, not always, but mostly 3 different fractions, fines, 3D or heavy material, and 2D and light material. All of them have similar steps, but of course the machines have to be slightly different to cater the different material properties, like the different size and different weight of the materials. Generally, we always take out ferrous metal with a magnet first, then we take out non-ferrous metal with an eddy current, and then we sort the material into different fractions by the near-infrared sorters, sometimes with a black sorter as well. That, again, depends on your product input and your desired product output. The functioning principle of the near-infrared sorting is mostly that the material goes on a conveying belt where it has some time to stabilize. So basically, mostly the belts are 4 meters long, so even bottles or trays, which might have some turbulence on the belt, have some time to settle and stay in the same position. Then it's passing a light bar, so basically some halogen lamps, and lighten up the material, and the reflection is taken by a hyperspectral imaging camera. Then it's processed, and the computer basically tells the valve bar which material to shoot out. So we use pressurized air nozzles to shoot out the material that shall be sorted out, and the rest just drops from the belt. This is how our detection bridge looks like. So you can see the yellow light basically, and the reflection is here just symbolized in red, where we have our hyperspectral imaging camera. Our control panel air conditioning unit is directly on the sensor bridge, so it's very easy to handle. The difference of Steinert compared to many other near-infrared sorters is the resolution. We have 256 measuring points, so you see on the right side we get a very detailed curve with even slight ups and downs to characterize the material, whereas a little bit simpler technology usually only has 60 measuring points where you get a more abstract curve, so some materials are not so easy to identify. Below you can see just as a to make it more visual how it would look like in pixels. For example, what we can do with this higher resolution is to separate PET trays and PET bottles just from the infrared spectrum. Because of the manufacturing process, they're slightly different in their spectrum, and only our camera can identify those differences. This would be an example of how PET bottles would look like after sorting. So basically they're taken out from all the other waste streams and then separated into green, blue, and transparent, for example. Then usually they get crushed and washed, and then you receive a relatively clean flake product, but still some contamination on it, mostly metals that come from the pre-processing or from the transportation. And in order to recycle those, of course, we also have our process steps, usually to take out again the ferrous metal, the iron parts, the non-ferrous metals such as copper, zinc, aluminium, and then to sort them either by type or by color. And especially for the black ones, then we have a separate process as well. This is our eddy current technology. So basically here we have a machine that has a magnetic drum that spins very fast with north and south pole alternating. inducing eddy current into conductive material, which is not magnetizable, such as, like I mentioned many times, copper and aluminium. And with this induction of the eddy current, it will basically push itself away from the magnet and thus getting separated from the other streams. And the flakes, for example, will drop and you will receive a clean metal product on the one side and some clean plastic fraction on the other side, which then have to be sorted by color, for which we have different technology also, either belt sorting, which is usually a little bit slower, lower capacity but higher purity, or chute sorters where the material is falling through the machine. Also always light is shining on it and the reflection is identified by color cameras. And the chute sorting is with a much higher capacity due to the speed that the material is passing through. Then you get your clean PET fraction as a clear material. Of course, you can still see some small contaminants of blue, for example, but it's usually acceptable to the manufacturers, depending on the color, of course. So usually a little bit of blue in the transparent is okay, green is less acceptable, and darker colors, of course, are not acceptable. And for other materials, non-PET, other polymers, usually they are getting separated in white and black and mixed fractions, depending on what the customer wants to do with it later on, of course. So let's talk about big data, which is very important for the future, to gain a lot of information and process them. All of our machines are available with a wide range of communication protocols and connections. Mostly the very easy one is potential-free contacts, but then of course Profibus and Profinet are the common standard, and the OPC UA for the communication of the data. So you can not only communicate or operate our machines from remote access, but also get the transmission of all the machine data and the product data for further processing. Steiner developed an intelligent remote system, basically a service tool that makes it very easy for the machines to communicate with each other, which brings down commissioning time, remote maintenance time, troubleshooting. Basically, you can operate or get the data from one machine over all the other machines to not have to move around all the different machines during commissioning. And also you can put the update on one machine and it will transfer to all the other machines in the same plant from the same machine family. Then we have the extension of it also, which is very important for our customers, that they can get all these data also in the operating room. Here, for example, you can see then that you get the data of the belt coverage, for example, that you can see which machine has which belt coverage, how much is it being used right now. A few examples where it can be very useful is, for example, to monitor the performance. On the left side, you see three different diagrams coming from three different machines. The first one is the basically pre-sorter that takes out PE. And the next one is a PE cleaner, which just makes sure that even more contaminants are sorted out, and which is not ejected but dropped from the first machine. Is the drop rest with much more different materials, for example. And if you combine all these graphs on the right side, you can then see basically you can control the performance of the first machine with the data from the other machines that you can calculate, or the program automatically calculates your purity and your recovery of the PE that you have and want to sort out. Another example would be the screen cut, for example. We monitor, or with our high resolution camera, we can also see the particle sizes. Of course, not as precisely as a laboratory screen, but a very good indication of the material sizes that are passing the belt. And on the left side, you see for the time period 1, for the first shift in the plant, a diagram of the different particle size distribution, and on the right side, or middle, for the time period 2, another curve, which you can see the material is suddenly getting a bit bigger, or smaller, sorry, because the data comes from the PE sorter after the screen with a bigger fraction of bigger 60 millimeter. So if it suddenly changes that much, you can see that something must be wrong with the screen, that suddenly you're getting or smaller material in the fraction of plus 60 millimeter. So most likely the belt, the screen is covered, allowing smaller particles not to pass through, but to go in the coarse fraction. And this is some use of knowing that something is wrong in your product without having to look on the screen constantly. Another example, similar with a 2D or 3D distribution. So here the PE sorter is after the ballistic separator. And the second shift suddenly noticed there's a lot of more 2D material compared to the first shift, which indicates that there's some issue with the ballistic separator that suddenly lets through more 2D material in the 3D fraction. Then we're coming to a big topic, AI, artificial intelligence, and how we can use it and how it can help us. Basically at Steinert, all our recipes, what we call it, is basically the applications, spectrums, and different materials are stored into our machines. So depending on the application the customer has, he can always select what materials he wants to sort out from this process. For example, if you have a light mixed waste fraction, you want to sort out all the PET bottles and PET trays, then you can select the right program and click on PET bottles and PET trays to be sorted out. And all of these recipes are are basically maintained in our database and then transferred to the AI database of the customer. So basically we combine a spectral database from the NIR camera and the database for intelligent object identification from the color camera in our system, and with the internet connection then can always update the customer's machines. And how do we build these databases? Basically we have to teach our machines first what materials it can expect. So we use mostly our test center to feed different materials to the machines and put it on the database. Sorry, I forgot to click. So basically the machines learns which types of materials are in that waste stream, and AI can help us to complete the database. For example, either tells us which objects are not, where we have not enough data and where we should feed more of the material, or doing some interpolation of the different different near-infrared spectrums. So it can help us always keep our database intact and also help us to more quickly make them learn different waste streams from different countries, for example, because especially the packaging looks different everywhere. And then, of course, with internet connection, we can directly update all of our customers' machines to keep them as intelligent as possible. And if we combine near-infrared and color camera spectrums, the AI can also put them together to have a more clear picture of different materials. For example, not only the near-infrared spectrum and not only the color and shape, but putting both together to help us identify then, for example, the PET bottle and the PET bottle for drinking water, for example, food-grade PET bottle, and the non-PET bottle for cleaning material, for example. Because the NIR, it will just see PET, but with the information of the color camera, it can identify either some residue in the bottle or also the label, for example, and then learn what type of bottle it is. And of course, this the updated database is then also always transferred to the customer to have a more intelligent sorting by NIR and color. Then I talked about our test center, which is very important for our R&D, but it's also important for our customers because we can always check the feasibility of different materials. Also for research institutes, we are getting some tasks sometimes to please identify how this is being able to be sorted. Also, packaging manufacturers are asking us to please test the new materials, whether they can be identified, because they have to be more and more responsible, of course, what they bring to the market, that it can later still be recycled. So in our test center, which is a industrial scale size, we can check the feasibility of different sorting processes, not only with our machines, but also with wind shifters and ballistic separators. We carry out the sorting trials, and we can also analyze, of course, the performance of it, which capacity, which yield, and which purity you can expect for the different sorting tasks. Then, of course, to maintain the machines and commission them, we have an after-sales service team of 40 technicians worldwide that commission over 400 machines per year. We conduct customer training, so our customers can operate the machines as smoothly as possible, either on our side or on customer side. And very important, of course, we do online remote maintenance, which helps us to solve about 70% of all issues online without having to send someone over. Only 30%, of course, somebody has to come sometimes to look for mechanical issues. And if the customers allows us to look into their machines, into their data, then of course we can also give proactive recommendations how to optimize the sorting process. These are some pictures from commissionings all over the world. And at the end, I'm not sure if it plays here, a video of a plant nearby Germany, so you can get some impression, but I don't think the video is playing. Then whoever's interested, it can be found on our YouTube or on Peritus YouTube as well. And if you have any questions, then please feel free to contact me, Samin, and we have a small booth below in the exhibition area. Thank you very much.
Thank you very much. So that was the solution that is being provided by Shine Art in Germany. And we were able to get a lot of insights from Mr. Midahov. And let's thank you very much once again. And the next presentation will be delivered by Ms. Oh Hae-jung, Senior Research Fellow at Chungnam Institute. Please welcome her with a big round of applause. Good afternoon. As introduced, I am Senior Research Fellow Oh Hae-jung at Chungnam Institute. So previously, he talked about technology-related stuff, and it was quite difficult to understand. And I know a lot of you are from Chungcheongnam-do province, so we know that we are considering a lot about plastic and what kind of strategies that we will take. So my presentation will be very short, about 15 minutes, but I will introduce what kind of strategies that we will do to advance plastic circular economy. So regarding plastic, we know that plastic waste continues to increase globally, and plastic waste is causing a lot of pollution globally. According to the OECD, by 2060, plastic waste generations is projected to increase 2.9 times compared to 2019, and its plastic accumulation in marine ecosystem is projected to increase by 3.5 times. So there are a lot of active international efforts are being made to end plastic pollution, and a lot of research are underway as well. And in 2024, negotiations was there was a resolution adopted by the United Nations in 2022. but there should be ongoing additional negotiations to finalize the agreements by 2025. And as our previous speaker mentioned, in Germany, a lot of efforts are being made as well. And we are also planning to mandate expanding the use of recycled plastic feedstock to 30% by 2030. And also, this might act as a trade barrier for plastic products exports in the future. And let's have a look at the Korean situation. Domestic plastic production and consumption are on an upward trend and are projected to continue increasing in the future as well. And with that, our environment division in Chungcheongnam province, we are coming up with various measures, and also the central government is also enacting legislation and preparing measures to transition to a circular economy society and reduce plastic use. And now this is the Chungcheongnam-do resource circulation promotion policy. We are the nation's first city to declare the special province for carbon neutral economy. And in terms of GRDP, we are number one nationwide, and also nation's first special province. And one of our five major goals is to make a circulation promotion policy. And another thing that we are emphasizing is to make a transition to a plastic circular economy society and implementing plastic free strategies based on this plan. And we also would like to connect different municipalities and institutions within our region. And also another thing is whether how we can do a feasibility study and make a basic plan. And last year, as a pilot project for high quality resource conversion of waste vinyl, we signed an MOU to activate chemical recycling. And we are now proceeding with various MOUs to utilize waste PET as well. And our governor is highly interested in recycling as well. So he is now also insisting the need for the plastic free strategies. And also, we started supporting this activation project, starting from the public institutions, including the county governments, provincial and city governments. And now we are expanding these efforts to the private sector and university level as well. There are a lot of universities in our area. So by next year, I think we will be able to expand the project to encourage those university students to participate in. So like upcycling or sorting and collecting. By utilizing artificial intelligence, we will be able to advance our efforts by utilizing the technology. And then let's have a look at the current status of plastic waste in Chungcheongnam-do. So Chungcheongnam-do's total waste generation stands at second highest nationwide. But there are some parts where our municipalities can take part in. But the important thing is what kind of material we can focus on. And plastic waste will be the first priority that we should address. Actually, and that is why we are doing this part three of the second session. So we know that the Chungcheongnam's plastic waste will increase in the future, and because we have a lot of plastic consumption and plastic waste. That's why we are projecting to do as much as recycling as possible. And also, I think household plastic generation could be also reduced, and not only households but industrial facilities or some restaurants. There are some plastics that are generated from these industrial facilities. But I think we should pay more attention to our daily use plastics. So when we have a look at these statistics, we can see what kind of, in which sector or what kind of plastic waste we should pay more attention to. And we also should think about what's the cause of these plastic waste. So, and we were able to see the household plastic recycling rate is very high, and also mixed disposal rate of plastic in Chungcheongnam household waste was about 84%. So among household waste, the mixed disposal rate for plastics was about 47%, which is very high. So I think it is important for us to sort waste. And when we sort this disposed waste, more than 80% of them are plastic. So we can see plastic is extensively used in agricultural production and packaging as well. So that is the current status. And Chungnam should establish tailored strategies to leverage its strength in swift policy and implementation to compensate for weakness. And because we are seeing a lot of opportunities and weaknesses and strengths at the same time, I think we should carefully devise our policy and to prepare a strong foundation to overcome and address the current status that we are facing. And by doing so, we will be able to make some management plans for vulnerable areas and prepare alternatives and our daily lives and agriculture and marine, and there are some parts where we can do well, including the daily life industry, agriculture, and marine. So I think we can become a leader in this part, and we can establish model cases. So and then to have a look at that, let me show you this diagram. And so by 2040, we are projecting to have net zero society, and we want to accelerate this timing 5 year earlier than we originally planned. And so what we would like to do is to reduce 30% of plastic waste and make recycling rate to become 85%. And this is the strategies for the four sectors that I've already mentioned: daily life, industry, agriculture, marine. Because of the time constraints, I think I'm gonna be brief to explain this part. But if you're curious, you can send me an email so that I can share this presentation material with you. And so, depending on which city and county, there were about 88% of plastic waste. But this is the overall average. So, depending on by regions, if you have a look at the map on the right up of this slide, you will see the differences. And so we can also have to make a tailored policy to make our own circular economy, and then also we can make some Chungcheongnam style plastic free circular economy model, and we can make some libraries or hospitals or schools or community centers that can be our pilot project. And we can also redesign the discharge and collection, transportation, sorting, recycle system. And we should focus on plastic waste. And to do so, I think because the recycling rate is falling short compared to other recycled resources. So I think maybe we can do some metropolitan level upcycling places linked to material banks and city county level. And in our region, I think there will be another forum other than this international forum. So I think there we will be able to share some policy measures or some action plans that we can put into a right place by having a close conversation and communication. And another thing is our implementation strategy. So underneath it, there are some detailed policy, but I don't think I will be able to introduce them all today. But in the industry level, I think it is crucial for us to create a cluster, and also we will have to make an ecosystem where we can be more friendly in recycling into the chemical use. And another thing is maybe we can utilize it for the construction sites. And moving forward, we do have some agricultural part. So, but to create agriculture and rural plastic circular economy project is something that we should think of. And another thing is the marine part. So there are some plastic waste that are generated from the industry level, but there are some of the parts that are generated from marine industry. So we need to create an infrastructure so that we can see the vulnerabilities and establish marine-based circular economy business models and complex spaces. Coastal areas are very important for our region. So to make plastic free area, I think we should make our environment more friendly to the plastic free. And we should not only make a system, and we should not only make environment, but we should think how we can make our environment that can allow our animals and a lot of a lot of creatures to live all together. So I think there could be some key policy initiatives based on these, and we can go through and we can review the key initiatives. And after reviewing it, I think we can expand it. So, presented in this three major categories, including urban, coastal, and rural, I think we can first have a look at the urban type and marine type and rural type at the same time. And through region specific pilot project considering local characteristics, and we will be able to identify tasks suitable for future policy expansion. And we can connect these clusters, and also we can establish a Chungnam style plastic circular economy. And this circular means we can also create jobs and also recycle it and use it as a new material. So it's a true circular economy. This is our motive that I got from the Switzerland. So they do not just recycle their plastic waste, but they try to use it to create some hub center and create jobs, and also do a lot of things by using plastic waste. So I think we can learn from their case and make our own Jungnam style plastic circular economy. And moving forward, rural type, we can make use of some smart farms technology. And why it is relevant to Chungcheongnam City is because there is something that we don't even realize, our resident even realize. GHG, greenhouse gas emissions. Do you know that our greenhouse vegetable cultivation uh, is third, stands at third nationwide, and we are the second most heated area nationwide? Because we operate smart farm, we are generating a lot of plastic waste by in the agricultural sector. So I think we need to recycle that plastic waste that are generated from the agriculture sector so that we can reuse it in the agricultural sector as well. And this is something that we should consider also. And to um, for these ideas to become a reality, of course, governance will be important, education and promotion, as well as system improvement. All these will play a great role. So we should take a look at it closely and monitor these things, these items. And last but not least, my presentations were very brief and I only touched upon the titles of each slide, so I'm very sorry for that. But actually, Chungcheongnam-do, we do have our own characteristics. So I think it is important to consider our regional characteristics. And it is important how we can put into reality by considering these regional characteristics. So, what's important is I think we need integrated management of cross departmental policies to establish circular economy systems across sectors. And we do have some schools and a lot of institutions. So I think we can establish governance, public and private cooperative governance systems such as a Plastic Circular Economy Council, and also policy dissemination through pilot model projects by type, securing national funding, etc. And I think additionally, enactment and revision of related ordinances considering regional characteristics will be very visible. And I think we can also establish a plastic waste inventory or dashboard so that we can clearly see and know what's the current situation, and to have a look at the current data. And that's it for my presentation. Thank you very much for your attention.
Through the presentation, we were able to understand that Chungcheongnam province had declared the carbon neutral and also circulation of economy. And thank you so much for the presentation, Ms. Oh Hae-jang.
발제입니다. 플라스틱
And we have last presenter. We will listen to Mr. Lee Dong-gyu about global trends in plastic-related agreements and international cooperation strategies, and he's co-representative of Climate Future.
네, 안녕하십니까.
Hello. I guess you might be wondering why former Latvia ambassador is here to talk about plastics. Before working as Latvia ambassador, I was in charge of environment and science issues in the Ministry of Foreign Affairs, and I was also in charge of UN plastic treaty negotiation and international cooperation while I was the director. And by that time, I was also directly involved with that process, so that's why I'm here to talk about plastic treaty negotiation. And I just heard two presentation, and one was about technological presentation, and the other was Dr. O's circulation of economy, and that was a very good presentation. And there was an opening ceremony in the morning, and I also attended different sessions after that. And Chungnam province is the one that is very much interested and also has leadership and very exemplary case regarding the carbon neutrality. And how can we push this to the international level, and from what perspective? I will briefly introduce. Regarding the background and the procedure was also covered by Dr. O, so I will skip that, and I will talk about the main contents of plastic treaty and our interests and position of Korea and other countries' position, and also Geneva summit result. And regarding the climate change, just transition is very important. And also, plastic is facing similar situation. Like Dr. O said, economy circulation, if that is well applied, that will also create jobs, and also energy transition caused by climate change. This will also create jobs if we, I mean, it can create a great synergy if we think plastic and climate change at the same time. And about this plastic issues, how can we cooperate internationally? In the UN Environment Program, this plastic issue had been constantly discussed, and this summer, I know that we have all suffered because of the climate change, and not just climate change, but also biodiversity, and also we have plastic issues. These are the three major issues regarding the environmental issue. Of course, plastics are very has a huge impact on the marine species, but this is also coming back to human being. So that's why it is also important as much as climate change. The fifth meeting was opened last year, December, in Busan, and we were supposed to adopt a plastic treaty after that, but international society had never completed anything uh, in a limited period. So, especially in a time like this, sensitive matters are discussed. And after that, in Geneva, a 5-2 meeting was held, session was held, and people said that we had reversed since the Busan session, and there will be another meeting afterwards. So let's take a look at the range of plastic treaty, a scope of plastic treaty, and what kind of items are included. And the scope is life cycle approach, which is about manufacturing plastics and the management of plastics, and all those will be included in the scope of plastics treaty. And international consensus has been made regarding that. And with the implementation, we need to reduce the amount of manufacturing, and Chungnam also has committed to do that. And also single-use plastic should be no longer be used. And this should be standardized for easy management. And I saw that machine from Steinheit, and that was amazing. That plastic selection was amazing. And this standardization can help labeling job much easier. And of course, plastic waste management is important. This is very catchy. And reuse, recycle issue. And what's important here is we have to cope with the climate change and circular economy, and we need budget. And for that, we have to deal with this as international issue. Then we need to provide support for developing countries, and that is also a very important factor. And financial support, and there's just transition. And just transition is the only subject without any controversy, which means all UN member countries are committed to just transition, and they know the necessity of just transition, and without that, this plastic issue will not be resolved either. Related to plastic issues, I would like to share some of the few key points. And I heard about life cycle approach recently, and do we need to apply regulation to all these procedures, or do we just need to limit this to the recycling scope? So there are some
미국 같은
controversies regarding that. And as for the US, they want this to be voluntary, but the treaty itself should be legally binding. But the US want to make this a voluntary treaty. And about the scope of treaty, we have not made a decision about the exact scope. And also chemical regulation, we need to think about that. I mean, chemicals are not just for plastic manufacturing. It is also used in petrochemical field, and the scope can be extended to petrochemical field. And regarding the financial matter, the advanced countries are trying to avoid high amount of levy, and the developing countries are also wanting more financial support about this. I have explained some of the reason of our conflict, and here it is. I mean, high ambition coalition is about stronger regulation, and there's plastic production and consumption, and strong implementation and financing mechanisms. And the opposite side, there's um, Arabic countries, Middle East countries that are producing oil, gas, and um, China and India is also included. And of course, Korea is not included with the opposing country. And if we consider all that, I heard that Korea is ranked number 4 or 5 regarding the petrochemical sector. And if we have to face this strong plastic treaty, then that will harm the petrochemical sector. And regarding the plastic issue, we already have consensus. And I think our only choice is to choose high ambition coalition. So I hope we can have a better leadership with initiative and like exiting from coal sector. I think we should get ready for just transition. Like I said, the US prefers voluntary approach. And this is position of Korea. Thankfully, we are environment advanced country. So our official alignment is tilted to high ambition coalition. And of course, petrochemical sector will hit hard with that. But we're also very good at biodegradation plastic, biodegrading plastic, and we're very good at recycling the plastic. And with this plastic treaty, maybe this can hold higher leverage to balance a plastic overproducing country. We can let them produce less, like such as countries like China or India. But there can be some difficult points. If we start from the material sanction, then we have to think about transition of the petrochemical, and also we need to think about the cost. So that's why we have to be tilted to high ambition collision, but we need to take balance. Last August, the government had made an agreement, and there was a strong divide between petrochemical oil producing nations and nations demanding strict production limits. And in particular, life cycle approach, which was discussed in Busan, is about regulating from the production phase and phasing out the plastic at the end. And that was excluded during Geneva session. So many experts criticized that we should not go backward regarding the discussion about the discussion. And I have many experience about these kinds of agreements in treaties, and when it comes to dealing with these sensitive matters, we should not complain about going backwards because we can go forward later.
저희도 지난 제네바 협상에서는
During the last session in Geneva,
날짜에 대해서도 합의를 못했고
they couldn't
제네바에서
reach a consensus about the next date of session.
그 다음 회의에서 이제 그걸 바탕으로
And
왜냐면 아까 너무
I mean,
비판과 실망이 컸기 때문에
there were huge disappointments
아니면
and criticism
부산에서 썼던
at
텍스트로
Geneva session.
이런 거에
So
대한
we were not able to, they were not able to make any decisions about the date and about the agenda. So it may take time longer than we think. And these kinds of international climate crisis, climate change negotiation, the US is very reluctant when it comes to environmental regulations. And let me talk about just transition. Like I said, about this climate change or plastic treaty, whenever we make a transition, people who are working in that field will be harmed, and that local region can be harmed. Or oil countries, Nigeria, those African countries, needs to be supported for better transition. I thought we don't need to support them because they are oil producing countries. But if you think about it, we are depending on those oil producing countries. We are importing crude oil from those countries, and we're building buildings in that country, and if one side goes down, it will create a chaos. It will hinder the transition. Then that will no longer be an issue of the oil producing country itself, and it will all lead to more chaos, and we can call that orderly transition. You've heard about this transition about when it comes to climate change, so you can understand what it means. Like the Governor Kim said, and National Assemblyman Kim said, this year the special act should be passed. Because of this economic issues, Chungnam province has many good cases and experiences accumulated. So we should not just follow the issue of climate change. So when the government pursue resolving this issue, maybe we can follow their direction. Let me talk about international cooperation strategy. Plastic issue is not limited to one country, one region. This is an obvious global region. Even though we clear up the ocean full of plastics, it will not be a resolution because China will eventually produce more plastic wastes, and Korea and China is discussing and having a discussion about this plastic waste issue. But there's the US and China conflict, and these geopolitical issues are hindering the progress of this discussion, and that will not go away any sooner, but we need to try to make a consensus. But recently, President Trump and China had a tariff discussion. I don't know how it will go, but in a situation where the international cooperation is difficult, maybe local government can take the lead because plastic issue is also important to them. So we can have initiative, and we also Chungnam also has a sister city in China. So from that perspective, plastic treaty, if that makes a progress and if that treaty is signed, then that will be helpful for the international cooperation, and that will be helpful for just transition and resolving plastic issues, because we're already building a good exemplary. Maybe we can take the leader, we can take initiative. Thank you for your attention.
Thank you very much. That was important keys for the international cooperation for plastic from international perspective, and MOU and agreements were mentioned about from him. Thank you very much once again. And now we will proceed with panel discussion. We will be joined by four experts as well as a moderator, but please hold on for a second as we are to set the stage. And after that, we will have in-depth discussion. Thank you.
네, 앞선 세 분의
Okay, so three previous presentations told us about how we can recycle plastic waste and how we can consume and recycle plastic use and how we can prevent plastic pollution. And the transition to a more recyclable economy is not a choice but a must. And the whole life cycle is very important for the future, and for that I think we will be able to have more in-depth discussions and look for more effective measures. I think we are now all set. So I would like to introduce our panelists today. So for our panel discussion, we are joined by Mr. Lee Jin-yong, who will serve as the moderator for today. And the panelists include the CEO of Indirection, Park Ji-hyung, is here with us. Also, Ms. Kim Hae-ju from our RC of East Asia Network, as well as Ms. Han Min-chi from the Korea Legislation Research Institute. Okay, let us begin. Since we are behind our schedule, we will have to talk briefly, but a lot of us were waiting for this session, for this panel discussion, so we will do as much as possible. So, Chungnam, from the Chungnam perspective, it is my first time to take a listen to Chungnam's perspective and their specific policies. So this is the ninth uh, time hosting this event, and after the government declared to realize net zero society, there were a lot of leading policies and initiatives that's been taken by the government, and I think it's very significant and meaningful to hold this event. And I think Chungnam is gonna become one of my favorite cities. And I think this conference will be a venue for us to discuss visible measures and prepare strategies for our future. As you know, the carbon neutrality it's important because of climate crisis, and international promises and agreements are very important going forward. And we are seeing a lot of changes globally, and we are seeing the need for carbon neutrality in many places around the world. And for that, I think there are three key points. First is the reduction, and the second is absorption, and the third is mitigation. So first, offset is very important as well. And so first of all, I think our key topic is pretty much related to the reduction part. Well, net zero and the carbon zero, all these items are things that I'm considering a lot too. And for that, reduction and plastic will be very important topic as well. So plastic recycling and its circular flow was our main topic for the third part. And there are, I think, as far as I know, there are four plans. First is to expand the use of recycled materials. Second is environmentally friendly packaging. And third, we will have to change the system. And fourth is a sorting system. A sorting system was touched by a German speaker, Mr. Middleoff, and I think we can talk about it a little bit more about that during our presentation. And another thing is what was mentioned by Mr. Lee. So what he introduced is the latest technologies and latest products to advance effectiveness of recycling plastic use. But the problem is, the price always. And I think all these will be the hurdles for us to make a progress in this plastic waste and recycling parts. And my question is, my first question is for the Germany. So you introduce an equipment, and how much is that? And could you please tell us about the expenses using that equipment?
Okay, thank you very much for that question. It's always a very difficult question because there are so many varieties of it, so many combinations of different machines, different setups, different types of sensors. So I don't know how to answer that question directly. Of course, you can buy one machine for around 100 to 2,000 euros, which I don't know is a big number in Korean won. Right. But important is that you have a plan set up that makes sense to actually bring the pure product that you need and to scale it up usually. That will make more sense than to buy a single machine to make a big effort.
저는 이제 뭐 여러 가지 뭐 장비
Also, equipment and its functions, depending on its functionality and also depending on the material of plastics,
따라서 사실 장비의
I know that the price of its equipment could differ by its functionality. But Chungnam, I think we can think of adapting that machine and equipment, and I think that will play a big role in Chungnam. So that's it for my first question. And next, I would like to talk about expanding the use of materials. And for that, I would like to ask some questions to our experts regarding that issue. Could you volunteer? So that means we should expand producing more high quality materials. Also, I think it's a freestyle discussion, so I would like to give question. So now quality of materials and ingredients are one of the hot topics these days. And Peritus technology, regarding that, do you think we can improve its quality? And this is my first question. And second is PET and PTT. The price of that are very low these days. But if we can utilize Peritus, and do you think it's going to be price competitive? And additionally, plastic raw materials price. It was about $100 in the past, but now it's about $65 to $70, which is reduced compared to past. So polyester price and other prices are getting lower. But now recycled plastic is the price of recycled plastics are very high. So what I want to ask is like bio-related materials or recycled plastics have higher prices than the conventional ones. So I think it's in terms of price competitiveness, I think it's not competitive at all. So I would like to ask you what kind of technological to what extent the current technology status is at now, and also as for the license issue, and is it harmful for our health? So these are my questions.
Thank you. A lot of questions. I didn't bring anything to write it down, but I hope to remember. Otherwise, please remind me if I didn't answer anything. First one, I already forgot. That's good. But in general, I wanted to say, of course, it's a problem, especially for my company, for me, for my job, that recycled plastic doesn't have a high value on the market right now. That it's much cheaper to produce virgin plastic. I think that's also one of the issues that Dr. Lee, talked about. That politicians have different interests, of course, in the different countries. So the oil-producing countries, of course, they're not promoting recycled plastic as much because they still want to use their reserves of oil for profit, which I can somehow understand. And it's very difficult to talk about it coming from Germany.
Can you please speak closer to the microphone?
Yeah. I think I hear myself. That's why maybe it seems louder in my ear. Sorry. So it's very difficult from a German point of view to talk about it very directly because, of course, we're in a very privileged situation in a very developed country with very limited natural resources. So we're not in the same position as, for example, Saudi Arabia, India, China that you talked about. But we notice, of course, especially my company, Steinert, In the waste division where I'm at, we are very dependent on the policies because mostly the product does not drive the economy, does not drive our economy, but the policies that it's just mandatory to recycle. It's a general problem, of course, that companies want to be profitable and don't have the incentives to recycle material because it's just cheaper the other way around. So, for example, to put a price on carbon is helping, but I don't know any country where the price on carbon emissions is already so high that it really makes sense to recycle the material instead of producing virgin material. So I think that's a global issue, and especially I feel it a lot in my job because right now it's not very economical to recycle plastic just because you want to make profit out of it. Mostly you do it because you have to, because the policymakers say we want to achieve certain recycling quota, which is necessary, of course, to prevent a lot of problems that we have, like climate change and a lot of plastics in the ocean. I don't see any other way than to promote to introduce higher recycling quota. For example, my colleagues from the metal department, they don't have that problem because the metal prices are high enough that recycling metal is already driving itself, basically. Was there any question I forgot? I'm sorry.
네, 충분히 답변이 된 것 같고요. 다 공통된
I think that answers the question. I think we are all sharing the similar issue, and these issues are not resolved yet. And regarding the climate change, I have one more question for you. And we discussed about plastic international treaty, and that is related to climate change. And environmental issues are becoming more serious every day. And the technology that you introduced today, how much will it contribute to the carbon neutrality? Do you have this in number in your company? Do you have this quantitative number? When you actually apply this recycling technology from your company, do you see the number?
I'm not sure if we have any specific numbers on how much we are contributing or how much CO2 emissions are saved because of our technology. Unfortunately not. Of course, we're also not the only company who does that, but a part of industry who tries to promote recycling to drive circular economy.
재활용 활용도를 높이기 위해서 지금
So to increase the rate of recycling, I think in order for these latest technology to work properly, I think we need to see what kind of benefits we can get it from and what kind of profits we can generate from. So, but these days, I don't think there are much benefits in using or recycling plastic, but these days what we need to do is to put more efforts to make high quality raw material, so the quality will be the key, and depending on the quality, I think the sorting technology will become a little bit different, and in that process, like contamination issues and other issues should be considered in the later. And technologies that's been introduced now, if that can be adapted well today, I think it will be very helpful. Well, the questions are two technology related questions, so I think we should shift our focus. Okay, so the raw material expansion, I think first is we should advance the current technology, of course. In that perspective, well, I'm working as a consultant, so I'm involved in a national R&D project as well. So advancement of sorting technology, we are also funding for that project as well. And as a person who is designing or planning for that project, I think it's a problem of adapting. So in Korea, you know, sorting are all mostly done manually, in Korea. So, advancing technology is very important, and it is the key for our future. But I think the reason why we have to adapt uh, auto sorting is, I think there are two purposes. First is because there are some waste or some contamination that can be discovered from the plastic waste. So I think the sorting technology should be more advanced. But in the case of Germany, which is advanced country, I know. I want to ask you how much auto sorting is being put in place in Germany, and how much manually it is done in Germany.
Okay, thank you for the question. I'm again sorry that I don't have an exact number, but from the sites that I've visited, as well as in Korea, as well as in several European countries, I also noticed that a lot of manual sorting is done here, and I talked with my colleague about it. That the big portion is not that it's not the available technology, I think, but that it's still profitable to do the hand sorting. Which, of course, it's good that it creates jobs, but in Germany, for example, it's just not feasible because we have, I think, a little bit more than double the minimum wage that Korea has. So there's only a few companies who do the hand picking at the very end of the process, where, of course, sometimes the human eye and the body can a little bit be quicker or more precise than the machines. But to handle the big capacities, the machines are definitely more economical, at least in Germany, Netherlands, Belgium, where I have visited plants. So in most of the Belgian plants, you don't see any hand picking, any hand sorting anymore.
뭐 선별하는 과정은 사실 기계적으로도
Well, I know that before sorting, prior to sorting, I know first of all it's been organized or like spreaded, and also sorting plastics from waste. All these are done by labor actually, but I know some of them are done by manually, semi manually. Prior to the sorting process, I know some parts require human intervention, but some parts are done by machines as well. And the next part is the environmental packaging. So we are trying to make a transition to use environmentally friendly packagings that can be used very environmentally and biodegradation. And I would like to ask for your opinions, everyone.
With the biodegradation, plastics are already applied to the packagings, and we, Korea, is not accepting biodegradation plastic yet because we already have this autonomous system built. I mean recycling system built, and recycling system should be able to accept this biodegradable plastics firsthand.
제 입장에서 자꾸 말씀드리는데 저는 이제
And
정책하거나 뭐 이런 이제 그런 컨설팅
I'm
기관이기 때문에
a
통계를
policy
조금 많이
related
보게
person
되겠습니다.
and I'm
통계를
consultant,
보니까
so I always concentrate
이제
on
바이오
statistics,
플라스틱으로
numbers.
만들어진 뭐 용기들이
If you look
얼마큼
at the
버려지고 있는지가 아직
biodegradable
통계로도 잡히고 있지 않습니다. 그러면
waste,
그런 바이오
and
플라스틱
this is
비중이
not
얼마큼 돼서 이거를 수용할 수 있는 용량이 어느 정도 용량의 시설이 필요하고
this cannot be
내년에
read
써갈
yet.
수
The
있는
number cannot be
기반적인
read regarding the
기반 하나가 없기 때문에
biodegradable
이
plastics. So there's
기반을 먼저
no
조금
foundation for that.
구축하는 것도
So I think we
재밌게
should
진행이 돼야지
lay a
지금 정부에서
foundation
일단은 막
to do
추진을
all
하고
this work.
있지만 그걸
Of
수용할
course,
수
the
있는
government
시스템이
is
같이 따라줘야
pushing
되지
this
않을까라는 생각이
biodegradable plastics,
예,
but
있습니다.
before that, we need to build a foundation. And like you said, in Italia, they have the system for biodegradable plastics, but we don't have the infrastructure. So we have to perform testing for that. And for rural area, they can test biodegradable plastics, and we have to see if that is actually degraded, and we have to see the fishery area if those can be also degraded at the ocean, and that is more realistic story. And we need to have a strategy to secure high quality material. So that's why we need to have this center built, because there are some of the centers that is local centers. They accept all kinds of waste, and they all go up on the conveyor belt. And apartments, they have plastic waste, and they don't bury them. They send that to the sorting field, and that's why they're bringing the material all together. So that's why we're trying to build a all-in-one line. Before it goes up the conveyor belt, we can have about 5 lines, including biodegradable plastics. Then we can secure high quality.
마지막
Thank you very much. Let's shift our gear to the last one, the designing of products so that we can make use of plastic in the recycling process and reduce its plastic waste. And also, Ms. Kim, could you please tell us about it? Okay, so biodegradable plastic will be my main point. So biodegradable plastic technology should be more advanced, and in terms of price and in terms of environment, I think there are still a lot of rooms for it to be improved, so that we can utilize it more. And additionally, when we are to say that plastic is biodegradable, it's just not melt away, but it takes a very long time to be degraded. So, because I'm at an ecological institute, marine creatures, they will have no choice but to consume that biodegradable plastics. So, globally, there are a lot of plastic production annually. So, of course, technological advancement will be very important to advance producing bioplastic. But at the same time, I think we should also put efforts to reduce use of plastic. So, for that, if I connect that to the design point of view, I think we need a lot of changes in producing products and goods. So when we monitor the current cases, we see mostly discovered plastic waste at coastal areas were something like polystyrene, and also styrofoams, and it's also it can generate microplastics as well. So I think we should also think about how we can reduce that styrofoam as well as plastic related products. So I think we have to think about how we can effectively reduce producing styrofoam and polystyrene, and I think it needs some policy efforts. And at the same time, we should also conduct some R&D And also, another thing that will be important is to take a moment to review the current status and monitor the current status to see what's the reality and what's the cause of it to come up with proper measures. So we can categorize each causes so that we can deal with each different problems. Okay, thank you very much. So there are a lot of arguments regarding the biodegradable plastic because how we will make 100% biodegradable plastic, that's a question globally. And of course, it will become dissolved to the nature one day, but the definition or its exact figures are uncertain yet. So after the breakdown, it can also generate microplastic or nanoplastic, and it will it will become some pollutant in the future as well. So I think these are something that we should consider. And there are a lot of concerns and considerations to be taken, but at the moment, I think I went to IS5 recently, and it is being conducted under a 100% consensus. But you know, underneath all the project and businesses, everyone's thoughts are different, and so pollutions caused by plastic waste and the human crisis due to that pollutions, all these are not actually felt by the public actually in reality. So I think that's the big issue, and globally I think first thing is that we need to raise awareness for that as well. And internationally, I think we can create a treaty so that we can tackle these issues all together. Now we are behind the schedule actually, so I would like to wrap up. But if you have any question, I think we can get one or two questions from the floor. Okay, please use the microphone for the interpretation. It cannot be translated if the microphone is turned off, so please use the microphone. Sorry, please use the microphone for the interpretation. Otherwise, we cannot provide simultaneous interpretation.
혹시 토론자분들께서 답해 주실 내용 있으시면 해주시면.
Can any of the panelists answer the question? I don't think this can provide the right answer, but as for sorting field for local government, no big companies can enter this market. So there are many problems related to that. Even though they have internal performance result, big companies cannot enter this market, and this is not limited to the global companies. So this is an issue. So that's why we are currently reviewing the situation. And then in agricultural vinyl plastic, and like Miss O mentioned,
하겠다고 얘기를 하셨었잖아요.
uh, it is said that electronic history record will be kept, and we have a similar system. The fisherman's net all has the name. So, but the participation rate is low and data is not credible. And sometimes the fisher nets are not matching the data. And there are some problems regarding that. So that's why we are always thinking about how we can bring this to the electronic system that you mentioned. So we have to learn from that, and we have to integrate the recycling process. And there's also heat degradation process. And also for electronic vinyl, even though we store them, there should be other additives inside material, and there's also soil, and I don't think this can be recycled. This is okay for the recycling. And in that case, not just this, but we have to think about a pyro process. And you mentioned the waste plastic, waste vinyl, and this should be different from the fisher net recycling, so, because the range is different and also the contamination level is different. So you have to consider that.
지금 시범 사업하고
So the pilot project that we are conducting now is not for the agriculture part, but for the daily use. That is the one that we are conducting, and also recycling to use in the chemical parts. And we do have separate independent facility for the sorting as well. But for that, we are doing our pilot project at the moment. And I think, for the agricultural purpose and industrial purpose, I think it's a story of the later parts. But we are trying to collect as many cases as possible so that we can take a look at it. Okay.
그 아까 한민지 박사님
Well, Miss An, Dr. An mentioned, and also you also mentioned about that. The Middleoff also mentioned the price of the plastic. And the quota implementation was also mentioned. In 2017, I worked in Germany. At that time, I had chance to meet somebody who works in the reusable energy part, and what he said was that one of the companies that specialize in wind power went bankrupt. And I asked why is that a good news, and he said actually renewable energy price was not that high at the time. So for that, the German government was providing a lot of support for that, but it started to reduce its initiatives and its incentives. And after that, because the government reduced its credits, there were companies that started going bankrupt, and that told us the technological issue should address the price issue. So that's the story that I wanted to share with you. So I think that's it. We can conclude our panel discussion. And once again, I would like to thank everyone for staying late with us. And If you have any questions, maybe we can talk about it more in the offline networking session. Thank you very much.